This is our next chapter, chapter 2, polynomials. Let us first discuss the definition. Before I start the definition, you see the topic polynomials in one variable. So while going for the polynomials, we will have only one variable in the polynomials, not two or three variables together in the polynomial. Okay, so while doing the polynomials, we will have either one variable x, for example, in the polynomial, or the variable y in the polynomial, or we cannot have both x and y in the polynomial, because it is a polynomial in one variable. Now first you see what is the definition. The algebraic expressions in one variable which have only whole numbers as the exponents of the variable are called polynomials in one variable. So while considering an algebraic expression, okay, if that particular algebraic expression has only whole numbers in the exponents of the variable, then they are called polynomials. That means all algebraic expressions cannot be polynomials. They need to satisfy a certain condition to become a polynomial. Let us see one by one these examples. Here you will understand how these algebraic expressions are polynomial. Some of them are polynomial and some of them are not polynomials. See here. First of all, look at this example, twice x square plus 5x minus 6. First thing is satisfied, it is in one variable, so it is in one variable. Alright, first thing is satisfied. Second one, you must now see the exponents of the variable. So variable is x, here the exponent is 1, here the exponent is 2. So both the exponents are whole numbers, positive, including 0. Okay, so whole numbers means 0, 1, 2, 3, etc, etc. So since these algebraic expressions are in one variable, okay, and also the variable x has the whole number 1 and 2, that means it is satisfying the condition of a polynomial. It is having one variable and the variables and the variable x has only whole number in the exponent, so it is a polynomial. Let us discuss the second one. Root 2x cube minus 4x square plus root 7x minus 3. Here you see it is in one variable x, so first condition is satisfied. Second condition, see the exponents. Here the exponent is 1, okay, here the exponent is 1, here the exponent of the variable is 2, here the exponent of the variable is 3. So the exponents are again whole numbers, so this is also a polynomial. Let us discuss example 3. Here the expression is root 8x square minus 5 by x plus 6. Here you see, first of all, it is in one variable, so first condition is satisfied, it is in one variable. Second one, you see the exponents. First of all, this x has exponent 2, alright, it is a whole number. But look at this 5 by x. If I rewrite this polynomial, if I rewrite this algebraic expression, it will be 8 root 8x square minus. Now 5 by x, x means 5 by x to the power 1. You have already learned if it is x to the power 1 in the denominator, in numerator it becomes x to the power 1 in the denominator, numerator it will be x to the power minus 1, okay, plus 6. Now see, when I have simplified this, it is in one variable x, alright. The variable has what type of exponents? Here it is 2, alright, it is a whole number. Here the exponent is minus 1, negative number, negative integer is minus 1 is a negative integer, that means it is not a whole number, so this example cannot be a polynomial. I think it is clear. Okay, let us see the next example 4. 9x cube minus 3 root 3x square by x plus 4. You see here it is in one variable x, alright, first one is okay. Second condition, the variable must have exponents as whole numbers. You see here it is x cube 3, exponent is 3, whole number, alright. Here you again see 3 root 3 x square by x, okay, 3 root 3 x square by x, this x is in the denominator, okay, this x is in the denominator and its exponent is x to the power 1. If I now simplify as I have shown in number 3, it will be 9x cube minus 3 root 3, try to understand, okay, 3 root 3 x square by x to the power 1. x square by x to the power 1. So it is in division now, same base, okay, same base. Then exponents will have to, and since it is under division, exponents you have to subtract. So it will be 3 root 3 x to the power 2 minus 1. 2 minus 1 is 1. So what is that? Only x plus 4. Now see, this is your 9x cube minus 3 root 3x plus 4 in one variable x, and the variable x has whole number only in the exponent, because this is 3, here the exponent is 1. So ultimately it is a polynomial. So this is a polynomial because both the exponent has got whole number in the exponent. Okay, next example. This is y cube plus 7 root 2. While considering the polynomials, right, you have to see only the variable. You totally have to ignore the number. Number can be rational, irrational, it can be any real number. So let us start. First of all, you see it is in one variable only. Y, it is only, the variable is y. Okay, next the exponent of the variable must be whole number. Now this exponent 3 of the variable y, 3 is a whole number, so the variable y has got a whole number in the exponent, so this is a polynomial. Okay, next example, 8 root y plus y. See here, let us simplify this. First of all, before you see the example is in one variable only, so first condition is satisfied, one variable. Second condition, the variable must have whole number in the exponent. Now if I root 8, okay, if I simplify this root 8, you see 8 into root 8. I have already mentioned in the first chapter that root 8 can be written as y to the power half, okay, plus y. Now see, this y, here the exponent is 1, whole number. This y, here the exponent is half, which is not a whole number, because the first whole number is 0, then 1. We do not have half in the whole number, so this half is not a whole number. Clear? That means since the exponent is not one of the exponent is not a whole number, this is not a polynomial. I'm taking the last example. This is root 2x. Be careful, this is root 2 into x. It is not whole root twice x. Okay, so root is there only in 2. Root 2x plus 9 by x. One thing is clear, it is only in one variable x. Okay, now let us find or check whether it is a polynomial or not. Now first of all, root 2 into x. So root 2 into x, if I write like this, okay, plus 9 by x, x is in the denominator, x to the power 1. If this x to the power 1 goes to the numerator, it will become 9 into x to the power minus 1. Now see, here this exponent is 1, this exponent is minus 1, this one is a whole number, this minus 1 is not a whole number. That means this example, whatever is given, is not a polynomial. So before I conclude the topic, once again I repeat, the exponents of the variable you need to check very carefully, and if you need simplification, you simplify, but you be careful that the exponent of the variable must be whole number only. That means the exponent of the variable can be any number starting with 0, 1, 2, 3 and so on. So it cannot be negative integers, it cannot be fractions, or it cannot be any other number other than whole numbers. Alright, thank you.